Hello everyone, this is Professor Sukruti Joshi from LG Institute of Engineering and Technology, Ahmedabad. I'm going to take the video lecture series on chemistry. The subject code for chemistry is 311001. In our previous sessions of this particular subject, we have started chapter number 6, which is fuel and combustion. In fuel and combustion, we have studied about the proximate analysis of coal, right? Which gives us an idea about the percentage of carbon which is present in that particular coal sample. And in this way, it will give us an idea about how many percentage of carbon is present. And depending upon that, what is the coal ranking of that particular sample, right? So, to again move ahead with this kind of analysis, we will take a look on ultimate analysis of coal, right? Ultimate analysis of coal is basically an elemental analysis and it is often known as qualitative analysis of coal. Remember it here properly, proximate analysis is the quantitative analysis while ultimate analysis is referred as the qualitative analysis of coal, right? This analysis involves the determination of carbon, hydrogen, nitrogen, sulfur and oxygen which is present in the coal sample, right? You need to understand it here that each and every element which is present inside the coal sample gives us an idea about the significance or the ranking of that coal. Okay, so here the first one is the determination of carbon and hydrogen. So what we need to do is, so what we need to do here is basically carbon and hydrogen of the coal are converted into CO2 and H2O respectively, and the gaseous products of the combustion are absorbed respectively in KOH and CaCl2 tubes of known weights. Okay, so now let's move ahead with the process that how you can get an idea about the carbon and hydrogen or the amount which is present inside the coal sample. Okay, so about 1 to 2 grams of accurately weighed coal sample is burned in current of oxygen in a combustion apparatus. Okay, so what will happen? This carbon and hydrogen gets converted into CO2 and H2O. Okay, and when it gets converted into CO2 and H2O, they will get absorbed in KOH and CaCl2 tubes, which is of known weights already. So the increase in the weights of this are then determined. They absorb the CO2, they absorb the H2O. So we have to weight it before that particular analysis, and after that analysis we get the change in weight in the particular tube. And when we get the change or increase in weight, it gives us an idea about the amount of CO2 and H2O which is present. Okay, and depending upon that, the carbon and hydrogen. Okay, let's take a look on this here. Carbon plus oxygen mixes together to form CO2. Now, when it is passed through KOH tube, so 2 KOH plus CO2 gives rise to K2CO3 plus H2O. Okay, how it is present, like when we get carbon, we get it combusted, so gets converted into CO2, but CO2 is absorbed by KOH and forms K2CO3. Similar way, we have hydrogen content in the coal sample. So hydrogen gets attached to the oxygen and convert itself into H2O. This H2O reacts with CaCl2, forms CaCl2 into 7H2O. In this manner, weight of both the tubes, which is KOH and CaCl2, is increased. Okay, here these are the formulas which can be used so that we get an idea about the percentage of carbon and percentage of hydrogen which is present in our sample. Percentage of carbon can be calculated by increase in the weight of KOH tube into 12 into 100 divided by weight of coal sample taken into 44. And percentage of hydrogen can be calculated by increase in the weight of CaCl2 tube into 2 into 100 divided by weight of coal sample taken into 18, right? So we are using here the molecular weight, the molecular formulas, right? Molecular weight, that is 44 CO2 and 12 is for our carbon. Similar way 18 is for water and 2 is for hydrogen, because we are taking here H2, so we have taken it here 2, right? So in this manner we can calculate the percentage of carbon and percentage of hydrogen using this particular analysis. Now let's do the qualitative analysis of nitrogen. So about 1 gram of accurately weighed powdered coal is heated with concentrated H2SO4 along with K2SO4, which acts as a catalyst in a long-necked Geldas flask. Understood it here properly? We have to take 1 gram of accurately weighed powdered coal, which is heated with concentrated H2SO4 along with K2SO4, which acts as a catalyst for that particular reaction in long-necked Geldas flask. We have to use here Geldas apparatus. Okay, the Geldas apparatus is widely used for the analysis of nitrogen in various samples, not only for coal but again for various samples. Okay, now let's move ahead in our process. After the solution becomes clear, it is treated with excess of KOH and the liberated ammonia is distilled over and absorbed in a known volume of standard acid solution. Okay, the unused acid is then determined by back titration with standard annual solution, and from the volume of acid used by ammonia liberated, the percentage of nitrogen in a coal sample can be calculated. So we get an idea about how many number of nitrogen is present in our coal sample. Okay, this is the method, or this method is known as Geldas method also. The apparatus which is used here is known as Geldas apparatus, and or we can say that it is Geldas flask. So in this manner it is continuously measured for various kinds of coal samples. Now let's move ahead and let's see what is the significance of ultimate analysis, right? As we all know that we determine here carbon, hydrogen and nitrogen, three things continuously, right? So carbon and hydrogen, what is the significance of it? So greater the percentage of carbon and hydrogen, better is the coal in quality and the calorific value is also better. However, hydrogen is mostly associated with the volatile matter and hence it affects the use to which the coal is put. We need to make sure that carbon always is beneficiary for us rather than that of hydrogen. Although hydrogen plays an important role into it, but carbon again is a very important part of any coal sample. Okay, let's move ahead to the next one, which is nitrogen. Nitrogen has no calorific value actually, and hence its presence is undesirable. So I should say that a good quality coal should have very little nitrogen content. So in this manner we have three different elements. Number 1, carbon. Number 2, hydrogen. Number 3, nitrogen. Carbon should present in a very high amount. Hydrogen should be present in moderate amount. And nitrogen should be there in a nominal amount or in a very little amount. If we want to consider our coal as a good coal sample or as a high calorific value sample, then here it has to be understood that it should be in this proportion only. Okay? Let's move ahead to the type of fuel which is known as gaseous fuels. Till now we have studied about the solid fuels, right, which involves wood, peat, lignite, bituminous coal, as well as anthracite. But along with the solid fuels, which are actually beneficiary for the industries, but not for household purposes, we came across the gaseous fuels. Nowadays, gaseous fuels are actually used everywhere. Even if we talk about CNG, PNG, or natural gases, normal gases, etc., they are widely used. So let's take a look on them. Let's take a composition of it and how they are widely applied in different manners. Okay, so the gaseous fuels are most preferred because of their ease of storage, because of their ease of transport, because of their ease of handling, and their ease of ignition. These are classified into two main types. First type is a primary fuel. Second type is a secondary fuels. Primary fuels are natural gases, or natural fuel is basically considered as natural gas. And if we want to take an example of secondary fuel, then we can get coal gas, CNG, and PNG. Right? These are the types which are obtained from natural gases. Let's take a look on natural gas, which is our first and which is our primary fuel. So, a natural gas is obtained from the wells dug in the earth during mining of the petroleum. It is mainly composed of methane and very small quantities of ethane along with other hydrocarbons. If the lower hydrocarbons are present, the gas is called dry gas or lean gas. But if the hydrocarbons having the higher molecules are present, the gas is known as rich or wet gas. Okay, two different types of natural gases are there. Number one, dry gas. Number two, wet gas. Rich or wet contains higher hydrocarbons. Dry or lean contains lower hydrocarbons. Right? In this manner, we can use them according to their applications. Generally, the calorific value of natural gas varies from 8,000 to 14,000 kilocalorie per meter cube. Because it is gas, we have to consider it into the unit which is kilocalorie per meter cube. Now, let's take a look on their applications. It is an excellent domestic fuel and industrial fuel. It is also used as a raw material for the manufacture of carbon black, methanol, and formaldehyde. As we have seen it in our earlier slide, that it is mainly manufactured of methane, so it is widely used in the manufacturing of methanol and formaldehyde also. Methane is the main component of natural gas, which is in microbiological fermentation gives synthetic proteins which are used as animal feed. Right? It is widely used in rural areas. We can come across them throughout any rural areas of India. Now, our next one is LPG, which is liquefied petroleum gas. So, liquefied petroleum gas is obtained from natural gas or as a byproduct in refineries during cracking of heavy petroleum products. Nowadays, LPG has been a common fuel for domestic purpose and is widely used in most of the industries. The main component of LPG are N-butane, that means normal butane, and isobutane. Right? We can came across this widely. LPG is generally kept in metallic cylinders attached with the burner through the pipe. It has two stoppers, one at the cylinder and one at the pipe or one at the burner. Right? This has a special order due to the presence of organic sulfides which are added specifically for safety measures. The characteristics of LPG involves a very high calorific value, that means 27,800 kilocalorie per meter cube. It gives less carbon monoxide and least unburnt hydrocarbons and creates a least pollution. Its storage is very easy and it is colorless in nature. It has a tendency to mix with air easily. Its burning gives no toxic gases, so it is very less toxic. It neither gives smoke nor ash content. Similar way, it is cheaper than gasoline and widely used in fuels also. Right? Now, let's take a look on their applications. So, in food industry, LPG is widely used in the food industry like hotels, restaurants, bakeries, canteens, etc. Low sulfur content and controllable temperature makes LPG the most preferred fuel in the food industry. Nowadays, PNG is making its stand, but LPG is widely used. Next industry is glass and ceramic industry. So the use of clean fuel like LPG enhances the product quality, thereby reducing the technical problems which are related to the manufacturing activity of glass and ceramic. Right? Widely used in building industry, it has been a premium gaseous fuel which makes it ideal for usage in cement manufacturing processes. Then it is used in automotive industry because it is widely advantageous, very low in sulfur, other matters, aromatics and other contaminations. Right? It is used for drying of the crops in farming industry also. This is all for this session. Next we will see in our next session. Thank you so much everyone.